Hello, I'm Mayank Pathak. I'm a local neurologist. I work very locally here across the parking lot at Parkinson's and Movement Disorders Institute. I also have my own practice in Orange, California. And as Justin Aquinas reminded me this morning, I've been involved with this organization for nigh on 20 years. 20 years. And some of you may recognize me, some of you may not. To give you a little visual, this was not me this year, but the year before at the 5K run. You may not have recognized me then. I did have the eye mask on the whole time, but that's me unmasked. And if anyone doubts my devotion, what you can't see in the photograph here is that I actually shaved my legs for this race with the green hot pants. So I've been asked to talk about pharmacology, about medicines for botulinum toxin, and oral medications and botulinum toxin, which is an injected medication. There are oral medications for different neurologic diseases. I'll leave it to you to decipher what type of medicine fixes what ailment from this cartoon. I will tell you that levodopa is the main type of medicine used to treat Parkinson's disease. So each of these characters kind of gets what they need. The only one of these that might have some application in dystonia and movement disorders is the last one there, Xanax. And we'll get to on the last slide. I only have one slide for the oral medications. There are no oral medications that are FDA approved for treating dystonia or spasmodic torticollis. We just co-opt medications from other diseases. And I've kind of divided these into categories. There are a group of medications that are named for the action that they have. They're called anticholinergic medications. You heard Dr. Drake Duane mention these. These are medications that are best known for their side effects. They dry you up. Dry mouth, dry eyes, decreased sweating, hot skin. Benadryl is a medication that has these properties, and these two other medications have the properties too. Back before they invented levodopa, and if you've ever watched this old movie from the 80s with Robert De Niro and Robin Williams, Awakenings, it's about when they started using levodopa for this type of stuff. They were treating a disease that no longer exists, and I can get into that if anybody asks about it. But before that, all we had were anticholinergic drugs. That's what we treated Parkinson's disease with, and that's what we treated dystonias with. Benzodiazepines, we are more familiar with these by their brand names. Valium, the previous slide had Xanax, clonazepam or Klonopin. So there's a whole bunch of these medications, this apam, that apam, the other apam. They're all benzodiazepines. They are what they used to call minor tranquilizers to differentiate them from the major tranquilizers. And just saying that, you can kind of guess what the side effects and limitations of these medications are. The Rolling Stones wrote a song about this medication here, Mother's Little Helper. And so they do have limitations, but they do have muscle relaxant properties. And so they can be used to alleviate some of the symptoms of dystonias and other disorders that cause muscle spasms. And then there are medications that just relieve the pain symptoms. Opioids, these are either medicines that are made directly from the Afghanistani poppy plant or are synthetic analogs of substances from that plant. We also know these by their more common names, and there are a whole family of these. They're pain medications. And then there are medicines that are labeled muscle relaxers. Many of them work in different ways, and they too can be used to relieve some of the symptoms, especially the symptoms of pain in people with dystonia. Any questions on oral medications? Because that's it. Yes, sir. By the way, I use all these medicines in my patients. So,
Klonopin, someone's telling me that can lead to, in later years, dementia. Have you ever heard of that?
As far as I know, the effects of these medications wear off when they leave your body. You can overdose on just about any of these medications up here. And if clonazepam causes something, then you can be sure that diazepam and alprazolam and the other azepams will cause it too. They are all very, very similar medications. They all work at the same chemical receptor in the body, in the nervous system.
And could you use benzos with muscle relaxers like in the same evening?
You can. It's a little like using scotch with vodka. It's just that side effects are additive,
Right.
but people can and do, including my patients.
Okay.
There are very, very few select people with a dystonia that responds to levodopa, but they are very few and far between, and I'm not sure I've ever encountered one. Perhaps Dr. Duane has. So I'm going to talk mostly about botulinum toxin. I'm going to try to get it all back on schedule. Botulinum toxin, just a show of hands, how many people have been treated with botulinum toxin in this room? So a good number of people. So botulinum is a toxin, and you must know that it is related to the disease called botulism. So I'm going to talk a little bit about the disease. I'm going to give you some background information, things maybe that you haven't heard before. I'm going to talk about the disease botulism, then about the development of botulinum toxin, and then how it works and its development as a medication. So botulinum toxin is made by this bacteria called Clostridium botulinum. This is what we call an anaerobic bacteria. It grows in airless environments. There are spores of it that are dormant in the soil, but the bacteria themselves grow in things like poorly canned food and poorly prepared or preserved meats. And classically, that's been blood sausage. I don't know if anybody here is a big fan of blood sausages, but they have been known to harbor the bacteria. Botulism is a disease. This is straight off of the NIH website on how to recognize botulism. If you look down here at the bottom, you see muscle weakness, and a lot of these symptoms and signs of the disease, botulism, can be related to muscle weakness. Slurred speech, weakness of the muscles of the mouth and tongue, blurred vision, weakness of the muscles that focus the lens of the eye, drooping eyelids, facial paralysis, nausea and vomiting, abdominal paralysis, urinary bladder paralysis, are all follow from muscle weakness. And there's some other effects in here, dry mouth and throat, that are what we call autonomic effects. And these days we usually call those side effects of botulinum toxin, although sometimes we use those side effects to our advantage when we're treating problems that involve maybe too much saliva production or too much tear production or drooling. Botulism, the disease, a history. For some reason, a lot of these reports came out of Germany. In the 18th and 19th century, reports were collected out of various regions of Germany. Germany wasn't a country yet, but the various states and principalities that made up Germany. And this man, Justinus Kerner, was the first one to describe it accurately as its own disease. He made very accurate descriptions of it, and he determined that it was a toxin, an actual poison. You have to remember, this is like back in the days when we didn't really have a developed germ theory of disease. We didn't know that germs cause disease yet. Sort of these years were years when Joseph Lister was active, and that sort of thing was just coming into focus. So he accurately described the disease and concluded that it was actually a poison, which he called a fat poison, and that it affected autonomic nerves. How did he know that? He actually took some. He scraped some material off of sausages that infected animals, and he actually tried it, and it caused dry mouth and dry eyes and so forth. There was a famous pickled ham that caused an outbreak in Germany, and from that ham was the first time that the bacteria C. difficile, Clostridium difficile, was isolated, and this man, Hermann von Ermingen, used it to do animal studies and determined that it indeed was the toxin and not the infection that produced the symptoms. And he also found that if the food was prepared properly, it would stop the proliferation of the bacteria, but the digestive system wouldn't. So you could, the toxin, not the bacteria, but the toxin survived the human gut. Most cases of botulism in the United States these days, in the 2010s, are actually infant botulism. The spores can lie dormant in the soil. The spores can also lie dormant in honey and other preserves, and can then proliferate as bacteria in the gut of infants. They usually don't do that for adults. Our gut bacteria, we have an entire microcosm of bacteria that live in our guts that prevent this from happening, but babies don't. So if babies get the spores in their guts, they can get botulism, the disease. And that's why you're not supposed to feed honey to babies, even today. There are something like 250 cases estimated in the US every year. Wound botulism is another source of botulism. Remember that botulinum bacteria grow in an airless environment, so they tend to proliferate in deep puncture wounds. I can remember the 90s when a certain mix of black tar heroin here in Southern California was causing a whole bunch of cases. I remember the case of a man who came in one year with botulism from injecting himself in the rear end. He actually ended up getting like a hemi-buttectomy to remove the entire large abscess, and he was paralyzed for a long time. Then, the following year, his wife came in. She also had wound botulism, again from sharing dirty needles, and she was paralyzed for 3 months. She spent 3 months on a breathing machine until she finally got better. She had a complete recovery, as near a complete recovery as you could ask for. But that was another case of botulism, and for some reason that has now gone away. I haven't seen one in a decade and a half. We know that, so now I'm going to talk more about the toxin itself and the development of the toxin. We know that somewhere in the 9th or 10th century, one of the Byzantine emperors issued an edict forbidding the production of blood sausages. Why do you think? We don't know why, but we think it's because outbreaks of botulism were associated with that. This is the only picture of him I found. Actually, I found a couple of pictures of him on the internet. I like this one because what's probably being depicted here is that he's supplicating himself before the Pope or something. But I'd like to think it's because he just ingested one of those aforementioned blood sausages, and perhaps the next morning with a shaky hand scribbled his edict. There's some evidence that Indian Maharajas, so going to my own home country, Indian Maharajas were advised to use preparations from spoiled food as a sort of poison of court intrigue. And the great thing about this was the poor sap wouldn't start showing symptoms until he went back to his own kingdom. And then some poor schmuck in his kitchens would get the blame. Weaponization. So I'm going to talk about weaponization and then pharmaceuticalization. The actual crystal substance of botulinum toxin, the first one isolated was the type A. That's the one that's most commonly used today. Isolated in the late 20s and just sat around in a lab until the outbreak of World War II. World War II, early in the war, and perhaps one can imagine the powers that be, fresh in their minds would have been the gas attacks in World War I, and what a terrible weapon that was. So they were immediately looking for nasty stuff to drop on the Japanese. This is before we were involved in the European theater. This would have been 41, 42. And it was being considered as a biological weapon. And microgram for microgram, weight per weight, it was more powerful than actual nerve gas, or at least the nerve gases that were available at the time. So everybody so it was, considered as a weapon. But it has a lot of limitations as a weapon. You pretty much have to run up to somebody with a syringe full of the stuff and inject them. And then you have to wait a week until it takes effect. So it made a poor bioweapon. Over the years, after the isolation of type A, there were multiple other types. You've heard a little bit about some of these, and now we have an X type that was just isolated. So there are several different types. The ones that are used for humans are A, B, F in Japan, and E is starting to come out. There's an E type that's coming out mostly for cosmetics. And who knows about type X? Type X promises to be very powerful. Whether it'll have medical applications remains to be seen. Pharmaceutical, so from weaponization to pharmaceuticalization, this man, Alan B. Scott, who I think is still around, first applied this to certain cross-eye disorders. So you have muscles behind your eye, like think about putting duct tape on a basketball and pulling the duct tape to move the basketball one way or another. You have muscles like that behind your eyeball. So he took certain people with cross-eye disorders. He would inject one or two selected muscles on one side or the other and bring the eyes back into alignment. So it worked for a little while, and then he later applied it to other diseases. So that brings us to cervical dystonia. Cervical dystonia. It was in the early to mid 80s when studies were being conducted on people with cervical dystonia. And these studies found that botulinum toxin was about equally effective in bringing the head more back towards a neutral alignment and also alleviating some of the pain associated with cervical dystonia. It was about 30 to 50% effective in those studies, which is what I advertise to my patients. And if you get better than that, then that's great. We always try for better than that. So that was mid-1980s. 1989, type A is licensed by the FDA as the commercial product Botulism. Again, the name evokes what it was originally used for, fixing cross-eye disorders. And then it was renamed Botox in 1991 and approved for cervical dystonia in 2000. I believe that I did my first cervical dystonia injections with Botox in approximately 1998 or 99. And that was very close to here, but in association with Dr. Daniel Trump. 91, we have Dysport. And we've already heard a little bit about these. 2000, we have Neuroblock, Myoblock, it's the same product, just renamed. And in 2010, we had Xeomin here in the United States. And in other countries, we have other toxins available. This is the lineup of the bottles of the toxins that are available here in the United States. Again, I'll skip over that. That was Dr. Dwayne's slide showed that as well. Pipeline products, I'll just very quickly, there are new types of toxins that are being studied. Most of them are for cosmetic use, and they're going to be marketed for cosmetic use. Why do you think that is? That's where the money is, of course. That is where the money is. So now, coming back, so we've gone to toxins, now come back to cervical dystonia, and I think this slide is appropriate because it actually shows what Dr. Drake Dwayne was talking about, which is that trauma can induce cervical dystonia. People didn't believe that for a long time, and it took some convincing by some people who've already been mentioned here today to convince people that that was a real thing. But I've seen it. I have patients whose dystonia has been induced by initial trauma. So to understand how botulinum toxin does what it does, I'm just going to digress one more time into some physiology on how the motor and movement system work. The main movement system of the brain starts with a neuron here in the cortex, a part that we call the motor cortex, and an electrical signal runs down the wire called an axon, down through the brainstem, crosses over the midline, and then jumps the signal to a second neuron, and then the electrical impulse, this is an electrical impulse, much like electrical impulse in an insulated wire, jumps the gap here, and then the electrical impulse goes to whichever muscle that it may go to, and then that muscle contracts. The muscle actually is relaxed and lengthened, and then it contracts and gets shorter, and when it gets shorter, it moves the body part. In this case, it flexes the arm. So let's go back and take a closer look at this junction between the nerve and the muscle, because that's where botulinum toxin does what it does. This junction, this is a beautiful micrograph of the junction between the nerve and the muscle. This is all muscle here. And you can see that junction right there. And let's zero in on this in a diagram right here. This is the end of the nerve. So this is all nerve on this side, and this is muscle on this side. So we've gotten closer and closer, and there's a gap or a junction between the two. And what happens is as the electrical impulse comes down this nerve, it causes these bubbles called vesicles to fuse with the outer membrane of the nerve axon and spill their contents into the cleft or the junction. In this case, these green balls represent the contents of those vesicles, and that is a neurotransmitter, a chemical called acetylcholine. The vesicles fuse with the membrane, spill out the acetylcholine, which diffuses across the gap and lands on these special receptors. These are receptors that just like to be stimulated by acetylcholine. Once they are stimulated by the acetylcholine, they set off a chain of events that causes the muscle cell to actually contract and get shorter. And when millions upon millions of those cells contract and get shorter, the whole muscle contracts and gets shorter and moves the body part. So how does botulinum toxin work at this junction? Here's a diagram of the botulinum toxin molecule. You can divide it into two bits, a large bit and a little bit. And they both have different functions. The large bit attaches to the membrane of the axon. Remember, this is all nerve here. The muscle is down here on the other side. The big bit is what attaches the molecule to the membrane. This induces the membrane to invaginate and take the Botox or botulinum toxin molecule within itself, and now it's a free-floating vesicle containing botulinum toxin inside the end of the axon. This is bad for the axon because what happens is very soon the little bit breaks off from the big bit, starts floating around in here and wreaking havoc. And the havoc that it wreaks is that it prevents these vesicles from fusing with the membrane and discharging their contents into the cleft. The different types of botulinum toxin, A, B, F, and so on, there are some differences in the way that they do this, but that is the gist of what they do. So they block the transmission between the end of the nerve and the beginning of the muscle. And then after a while, the nerve terminal actually starts to grow back and repair itself. So, I originally purchased this cartoon because I was giving this same talk to the group in Las Vegas. So I thought this would be an appropriate cartoon for Las Vegas. I don't know how appropriate it is for this setting, but I hope you'll forgive me. But it does bring us back to torticollis and how it helps torticollis. Torticollis is here exemplified by this dashing fellow right here, who is showing us that in this particular case, one muscle is bulging out and causing the head to twist and tilt. This is the most commonly injected muscle for torticollis. It's called the sternocleidomastoid muscle. So if you inject botulinum toxin in this particular muscle, it will do its magic at the neuromuscular junction and stop the nerves from telling this muscle what to do. The brain is telling the nerve cells, and the nerve cells are telling the muscle, but it stops it at the neuromuscular junction. Now, this muscle relaxes. It's got no input, nothing telling it what to do, and the head position may go from here to here, a little better. It won't be perfect. You don't want to over-inject. And other muscles, it's not there. Usually not one muscle is involved. Many different muscles are involved. Another common muscle involved is the trapezius muscle. This is the muscle that pulls up the shoulder. And that's probably the second most common injected muscle in people with torticollis, cervical dystonia. You put your injection here into the trapezius muscle, and the shoulder begins to drop and relax. Unfortunately, it doesn't stop the bald spot from getting bigger and bigger as the years go by. And this is also why Botox has been applied to cosmetic uses. It actually doesn't do anything to the wrinkles. All it does is it weakens these bacon strip muscles that we've got under our face skin that make all our exquisite facial movements. It weakens or even paralyzes them depending on how much you inject, and so you sacrifice the ability to make exquisite facial expressions, which you would think would be very important to people like actors, but what you get is a more smooth and placid appearing countenance. And that is the trade-off. And that's one of our illustrations from our book on how to inject Botox for all kinds of things that are FDA approved and things that are not FDA approved. And that is, I've burned through this lecture. I've got us back on track.